Thank you for the introduction. Welcome everyone to the last talk of today. My name is Michael. I'm going to be speaking about Go Protobuf. Specifically, this presentation has three parts. We just saw that about half of you are familiar with Go Protobuf. For the other half, I'm going to do a quick introduction. Then I'm going to talk about what we have released most recently, which is the Opaque API. And then lastly, I'm also going to talk a little bit about rewriting Go code to the Opaque API. So let's start at the very beginning. The use case we want to look at is that we want to transfer data between systems. Now, we've all programmed, probably, and a natural answer might be, well, let's just use JSON, right? OK, so you define a Go type, like you can see on the left-hand side of the slide, just like a log entry type, and it has three fields: backend server, IP address, and request size. And then you fill in some values, and the result might look like what you see on the right-hand side of the slide, right? Like a nice JSON value. Everything is fine. But it turns out that the JSON spec is not actually very rigorous. Like, if you copy the value that we saw on the previous slide into your web browser's JavaScript console and you parse it as JSON, it'll work, like you see in the first line. But if you increment the number to 85 in the end, it parses to 84? How can that be right? And it turns out it is right because JavaScript uses arbitrary precision floats and JSON specifies it as such. So it is sort of up to you to ensure that your systems use compatible types in the way that they use JSON. Otherwise, that sort of thing might happen. So how does Protobuf compare? If you looked on protobuf.dev, the official website, or the Wikipedia article, you might find an introduction where it defines Protobuf as Google's language-neutral data interchange format. And each word in that definition pulls some weight. So the data interchange hints at the use case. We want to use this to encode data in the boundaries between systems. We do not want to design like a particularly efficient column storage database for like live queries, right? These are very different formats that you would need for that. So Protobuf is for data interchange. Then the language neutral gets at the fact that typically when you want to exchange data between different systems, they're not all programmed in the same programming language. So it is important that you can use protocol buffers in a large number of languages. Then the Google here means, you know, we developed it, we continue maintaining it, and the format in the end means that Protobuf declares its own wire format, and we're going to take a look at how that looks like in just a sec. But if we wanted to get started with using Protobuf for the same use case that we saw on the earlier slide, the first step that we would need to do is we would need to define a .proto file, which could look like this on the slide here. So you can see the first line says edition equals 2023. I'm going to talk about that in a little bit. Then we declare a package called log, just for namespacing if you have many protos. And then you see something that looks almost like the type definition on the previous slide, which is just message log entry. It has the same fields of the same types, but the one change here is that each of the fields has a field number. All right. So the Protobuf workflow is as follows. The first step is you create a .proto file. This is what we just had on the slide. The next step would be you call protoc, the Protobuf compiler, in order to generate code in the language that you want to work in from that .proto file. But the .proto file would be the same across languages. And then once you have that code generated, you would include it in your project. And from there on out, you can use Protobuf's encode and decode functions and so on to serialize, share, and deserialize your data. So what does the generated code look like? Well, when you call protoc, it will actually generate fields that look pretty similar to what we would have hand-rolled on the example before. So you can see we have a package log, pb. The pb suffix is sort of a convention, so like all of your Protobuf imports should end in pb. At least that's the way we do it, so that you can quickly see what is like generated code, what isn't. And then you see we have a type log entry, just like we would have written by hand. It just has like a couple more internal fields. Like, for example, the first one, like internal Protobuf message state, and there's a couple of others. All right, so now that we have this generated code and we include it in our project, we could write a program like this. This is sort of like the simplest protobuf using program that you could think of, where we just declare a struct literal of that type we just defined. We fill in a couple of values, and then instead of saying json.marshal, we just call proto.marshal, and it encodes it into protobuf wire format for us. Then we just write these bytes to standard output, and that's like sort of a really minimal demo program. Now, if we run this, you will just see like binary data. So what can we do in order to make that more readable? There are two ways. One of them is we just feed the output into hexdump, and then it'll display like a human-readable version of this. And you can see in the right-hand side that the values like the Zurich 1 and the IPv6 localhost IP address are still in there, but like the field names no longer are, in contrast to JSON. And in fact, if you wanted to like dig deeper into the wire format, there's a great tool called Protoscope. It's not something that end users would really need to run, but people who work on protobuf like me are very happy about this tool. And I just want to show it to sort of illustrate how the wire format works. So you can see that instead of having sort of in JSON you would have the field names, in protobuf you just have the numbers, right? So the names are entirely lost, and protobuf works with the numbers. All right, so to recap, how do the two compare? So before we recap, a fun fact, both protobuf and JSON were actually invented independently in the year 2000. And for those of you who haven't been around in 2000, the big thing for like encoding data was XML back then, right? So the question often really isn't, should you prefer protobuf over JSON? But I'm still giving you this just to give you like a rough categorization so that you can decide when to use protobuf and when not. So if you view protobuf through the lens of, oh, it was created when XML was around, you will recognize a couple of the parts of XML. Like XML also defines a schema, protobuf includes the schema with validation. Protobuf is very well suited for backwards and forwards compatible system design because it will pass unknown bytes through, so you will never lose data because you have a non-updated type definition or something like that. Also, as I explained with the example earlier, protobuf has cleaner type semantics compared to, for example, JSON. So you can be sure that if you have like an int64 on one system, it will come out as an int64 on the other side, right? But then most importantly, most people make the choice based on efficiency. So protobuf encodes much more efficiently, meaning that the output, like the wire format, the binary stuff I showed earlier, is faster, is generated faster and comes out smaller. So the downside of that, obviously, is that if you have this more efficient binary format, it's no longer human readable like JSON. So if you sort of asked me when would I use one over the other, I would say, like, for example, for any of the components in my smart home where I have like microcontrollers and Raspberry Pis and stuff, I would definitely opt for JSON, right? Just because it's like so well known, it's easy to get started, it's human readable, I can just observe it. But if I were to build like a multi-million-dollar batch data analysis pipeline, I would definitely reach for protobuf just for the efficiency and also for the rigor that it brings to the system, right? All right, so now there was one thing in there which might have surprised some of you. So you might have expected that each .proto file starts with a syntax equals proto2 or a syntax equals proto3 line, depending on which version of protobuf you use. And then I showed a thing where it was edition equals 2023. So what's that? Protobuf editions, you can kind of think of them like the Go language version in go.mod, in that the year of the edition just specifies the default behaviors. And the important bit about this design is that it allows for a fine-grained incremental migration through what we call edition features. So each of the edition year numbers just declare sort of this feature has that default, this feature has that default. But if you want to override the behavior, you can do that. And you can do that on a per file level, per message level, or even per field level. And I've shown an example here on the slide where I have like this log entry. Let's assume that it came from an old like syntax equals proto2 .proto file. And one of the fields was marked as required. Now, in edition 2023, the default is optional, not required. But we can still set this edition feature to retain the existing behavior. And then once we actually migrate the surrounding code that uses these fields, we can change or introduce a new field, right? All right, so with the general introduction out of the way, let's talk about the latest development, and that is the launch of the Opaque API, which happened in December 2024, so just half a year ago. Let's recap the Protobuf workflow. So we've just gone through all of these stages, and to be clear, the Opaque API is not changing anything about like the .proto files or anything about the Protobuf serialize and deserialize functions that you would use in your code. Like that all stays the same. The thing that changes is only the generated code. So the Opaque API is a new version of the generated code. Before I can describe what really changes, let's dive into the generated code just a little bit more. So if we look at the log PB again with like the old API, not even the Opaque, like just the old stuff that we had previously, we can see that in addition to the fields, there were actually a couple of getter methods, which I haven't talked about before. And these are good to use for multiple reasons. So let's assume you wanted to access the backend server field. And if you reached directly for the struct field, if the field isn't set, you would just get like the 0 value. So in this case, like a nil pointer. But if you actually declared a default value in your .proto file, the getter is what returns it to you. And also, getters are always nil safe. So that means you can call them on like deeply nested message structures, where otherwise you would need to have this chain of, oh, is this top level field set? And if so, is the next level field set? And if so, get that field. And with the getters, you can just be like, get this, get that, and it'll just check for nils implicitly. So the getters have always been there. Now, one more thing we need to clarify before we get into the comparison is the concept of field presence. So what does it mean? It just means whether a message field is set or not set. And the model that Go Protobuf uses for modeling presence is Go Protobuf models presence using pointers. So here are 3 examples of how you would work with that pointer-based API. In the first example, we said entry.backendServer equals proto.string Zurich1. And we've heard this in previous talks today. This is just a helper function that just gives you a pointer to this value, right? So in the first case, it would mean the field is set, and it contains the value string Zurich1. If we wanted to still set it, but explicitly to an empty value, we would use the same thing, just make the value empty, right? So in the second case, the field would be set, but the value is an empty string. And in the third field, in the third case, the field is not set at all, right? We just set entry.backendServer to a nil pointer. Okay, so now you might be surprised again. Like you might be using Protobuf and you haven't actually seen pointers at all in your usage. So let me give you a little bit of a history lesson here. So in Proto 2, which came out in 2008, explicit presence was the default and only behavior. So you would always have to use these pointers. Then, almost a decade later, Proto 3 came out as the successor, and it introduced what we call implicit presence, where there's no pointers, and the field is considered set if its value is different from the 0 value. So that means if you have, for example, a message that only contains a Boolean, if you set that Boolean to false, which is the 0 value, and encode it, it'll be an empty byte slice. Right, so that's sort of a little bit surprising, and developers who were using Proto 3 weren't really all that happy about having to introduce a tri-state enum every time they wanted to distinguish a bool that was set to false or not set and implicitly false. So later on, Proto 3 also got explicit presence through the optional keyword. And now with edition 2023, again, almost a decade later, it's explicit presence again, and I think from here on out it will just be explicit presence because the implicit approach has sort of failed. So if you were to ask me how would you characterize the Opaque API, I would say the Opaque API uncouples the generated code API from the in-memory representation. So what does that mean? If we look at the generated code now for the Opaque API, it looks pretty similar compared to before, but there are a couple of differences. So first of all, the fields are no longer exported, so you can't reach for them directly. And just to make it very clear that this is not sort of an oversight, but intentional, we've added xxx_hidden in front. So at the very latest in code review time, it will be very awkward trying to justify that you did that and you meant it, right? But in addition to the getters, which we've had before, now there's a couple of new accessor methods which allow you to do all the things that you were doing before. So we now also need a hazer and a setter and a clearer and so on, right? Like for a one-off, there's even more. All right, so why are we doing this change? Well, it's an optimization. This causes less memory usage. So when we're using a pointer to model presence, if you think about it, presence is a logical bit of information. It's yes or no, right? And if we use a pointer, that means we add a 64-bit word for like 1 bit of information. So it's quite some overhead. In comparison, the Opaque API uses bit fields for presence, so we can actually use 1 bit per field and not like the 64-bit overhead. Also, requiring fewer allocations is just faster in general, right? So now we're no longer using pointer types for elementary fields. For the other fields, maybe in the future, this optimization is less profitable for the other types, but maybe we'll still do it for a different reason later. But you can see in the benchmark results that I've put on the slide here that depending on the use case, this comes out either neutral or much beneficial, right? So in the second 2 use cases with the 2 examples from search indexing, we have the allocations drop by half, right? And the reason why the production use case here doesn't really benefit from this optimization is because its message structure is so different. So it just uses fields which we haven't changed the representation of, and it mostly uses like messages that are nested to like signal things. So that's why for those it's neutral, and for the others it's a nice speed up. Also, doing the API this way also allows us to implement features that we could not implement before, notably lazy decoding. So because all of the field access now has to go through the accessors, that means that we can safely delay the decoding work until any actual field access happens. However, messages are still verified at unmarshal time. And it has to be this way, because if you look at the previous slide with all of the new accessor methods, you can see that they don't return an error. And it would be super inconvenient if each of them returned an error, and you would have to handle like errors for each field access. So with lazy decoding, you still call proto.unmarshal. It still checks for errors at that point, but that's actually faster than doing the full unmarshalling and all of the allocations and so on. So depending on the use case, like if your application has this usage pattern where it reads a lot of data, but then only works with a subset and produces like maybe a report of some sort, then this approach can like save a lot of work. And that's why it's such a nice optimization. All right, there's a couple of more things, and I don't want to bore you with all of the details. You can actually refer to the Go blog post about the Opaque API if you want to learn all of the other things, like, for example, safety mistakes like accidental sharing or incorrect pointer comparison, and even accidental use of Go reflection are all like safety issues that we're addressing with the new API. And sort of looking more into the future, with that large API migration now mostly behind us, we're looking into more optimizations. Like one of the issues that I've sort of hinted at in the previous slide is that Protobuf performance is very, very dependent on your use case. Like your message declaration will really determine the performance. So one of the issues is that as we look into like, maybe we could do an optimization here, it always turns out that there's another service over there that doesn't really benefit from it. So we always need to have these sort of like global improvements, right? And by using profiles, maybe we could move our decisions closer to like a specific compilation for a specific program and thereby unlock even more performance. But that's speculative. Now that you know what the Opaque API roughly is, let's start the third part of this talk, where I'm going to show you how to rewrite Go code to the Opaque API as an example for code rewriting. So the short summary is just follow our migration guide. I'm not going to explain to you exactly how it works, right? But the gist of it is that there is a tool which is called Open to Opaque. And if you install that tool, this tool will allow you to rewrite your Go packages from using the old API, like with the direct field access, to the new API with all of these getters. And you just need to specify like one or more Go packages in your project, and it'll do the rest. So what do I mean when I say that? This is an actual example, right? Like on the top, you have the log pb.log entry type that we've worked with on the previous examples as well. Maybe you would check if the IP address is set, and if so, you would need to redact it for privacy reasons. And when you run Open to Opaque, it would rewrite your code as follows. So it would replace the not equals nil check with just the has, and then it would call set and get instead of accessing the field directly. All right, so Whenever we're talking about rewriting Go code, one sort of mental reference that I like to speak about is what I call the complexity ladder of changing Go code, where it ranges from very easy to very powerful. And the most easiest is you just use textual find and replace, right? So you can just like open any editor you have and find and replace, and you'll get actually pretty far with that very simplistic strategy, because find and replace is more powerful in Go thanks to GoFmt, right? Because of the way that we format all of our code identically means that there's a lot less wiggle room in the sort of patterns and syntax that people can use to express concepts. So in other languages, like your find and replace patterns would need to be more elaborate. And that's a very cool realization. The next obvious step up from textual find and replace, of course, is using regular expression find and replace, which gives you a little bit more power, but ultimately also falls short. So the next step you would reach for is the AST. This is the abstract syntax tree, which is the technical term for how a compiler understands and thinks about the source code that you give it. So with the Go tooling, you can actually get an abstract syntax tree, or build one rather, of one or more .go file. And all you need is just the file itself, right? So it doesn't even necessarily need to compile. You could still build the AST of it. And this gives you a lot of power, a lot of flexibility. So you could look at parts of the AST and change it. The next step up from here is a type-checked AST. Because if you only have the AST, that means you have all of the identifiers, but you don't necessarily know what they mean, like what they refer to, right? They could be like a reference to another package, and then you would also need to inspect that package to learn about what it really is. So with a type-checked AST, what that means is after you build an AST, you just run Go's type checker on it. But there is also a requirement here which introduces sort of a little barrier between the AST and the type-checked AST step, which is that the type-checked AST needs a full Go package, right? Because in Go, the unit of compilation isn't a single file, it's a Go package. So you need to have all of the files of that package and also its direct dependencies. So you have the type information, and if there's like any calls to CGO, then you better have like a compiler that works well enough to, you see it gets tricky pretty quickly. So for some of the tools, I actually prefer it to just work with the AST, even though it's less powerful just because it doesn't have like all of these requirements that you need to fulfill in order to get to the type-checked AST. And then there's only one more step in my mental model, at least. Maybe you can enlighten me about more later on if you want. And that is whole program analysis, where the difference is that previously I said for the type-checked AST you need a whole Go package. And for whole program analysis, you just need all of the Go packages that make up this program. And then you have all of the information and you can do any sort of analysis. But it's probably also prohibitively complicated and long-running. All right, so the Open to Opaque tool specifically makes for an example of rewriting code, obviously, and I'm just going to explain to you how we built it, and maybe you can then look at it if the details interest you more, maybe for your own tooling. So we mostly use the standard library to work with Go code, and Go positions us really well. So we have the go/parser package from the standard library, which you can use to read .go files. We have the go/types package in the standard library, which allows type checking. The go/AST package is for manipulating the AST. And then we have one non-standard library package, which is Dave's DST package. And the D in DST stands for decorated, because there is one issue with the Go AST package, and that is that it sometimes loses decorations, meaning comments. And that's really unfortunate, and it is like a known issue, and we want to fix it in an upcoming version of Go. But until it is fixed, we're just going to have to rely on Dave's trusty old DST package. And then to sort of complete that chain, there's the go/format package, which allows you to pretty print the source code and then write it out. And there's one more package that is not strictly speaking in the standard library, but in like the X namespace, which is go/packages from the X/tools repository. And maybe we should make that more discoverable at some point. But essentially, this is a package which takes all of the hard work out of the loading stage, which you need for a type-checked AST. So the go/packages package shells out to the Go tool via the Go packages driver, or to the Blaze tool, or to any other sort of organization, internal or custom build system that you might have. So this is your extension point to teach Go tooling like this one about your compilation structure. All right, and then what sort of blew my mind, like I didn't author Open2Opaque from the start. I joined the team afterwards, and like Open2Opaque is one of the most complex rewriting tools I've ever worked with. And I've done a couple of migrations in my career with like thousands of servers changed, but this is more complicated. So Open2Opaque is in fact a multi-pass rewriting tool. And what I mean by that is that if you consider the code at the top where we check if the backend server field is non-nil, and if so, replace its value, then there's multiple passes involved in translating that code. So the first pass, the has pass, first rewrites the code to use the has accessor. So far, so good. But by changing to the has accessor, the variable f has gotten lost. So what do we do? Well, the has pass could either know everything also about setters and so on, but then your logic becomes a pretty big ball of spaghetti pretty quickly. So instead, what we do is we turn f back into a reference to entry.backendServer, and then there's the set pass, which picks that up and turns it into the eventual final form of setBackendServer. So, in conclusion, you might be wondering, is the Opaque API ready? Like, it's just been out for half a year, seems pretty fresh, right? But in fact, we have saved hundreds of thousands of CPU cores Google internally, and we hope that the Opaque API will also allow you to save some cores if you're a big Protobuf user. In order to do this, we had to land well over 100,000 code changes to our monorepo, which was probably one of the largest changes, at least in Go, that we've done. I mean, of course, there's like sometimes trivial changes like just Go-fumped everything. I'm not going to count that, but like this migration just touched almost every program at Google because we use Protobuf as our main interchange format, so every non-trivial program uses Protobuf in one way or another. And you might be wondering, well, is it stable? Is it ready yet? And I can tell you that over 98% of Google production is on the Opaque API, so there's no reason for you to wait it out. In fact, if we do, as we do follow-up feature development and further optimizations and so on, those will very likely target the Opaque API. So we hope that you'll eventually also migrate to the Opaque API, or at least use it for your new developments. All right, so with that, I'm going to refer you to two good sources of further information. There's protobuf.dev, which is the official website. It should teach you and tell you everything, and if not, please file an issue, and we'd like to improve it. And the second resource I'd like to plug is the Go blog. Of course, I hope by now you're all subscribed, but it is worth just calling it out. There's so much good content there. There's like blog posts about Protobuf evolution and all sorts of other things as well. So with that, thank you so much for listening, and enjoy the rest of the conference.